You have written yesterday related to candidate elimination. See, now I'm able to share the screen. Are you all ready with your idea how to work with candidate elimination? So just I project the screen, whatever we have discussed in our previous class, just recollect 1 minute and then go. Okay. See, now we have studied about the Western space in our previous class, and we have seen the where the Western space will list all feasible hypotheses based on the training data. Then next one we have seen the diagram of Western space. Okay, so generally in terms of your candidate elimination algorithm and in Western space, the hypothesis will move right from our general to specific. Okay, right from general to specific. Suppose if then instances are negative, then they are specialized to general descriptions, and if the instances are positive, they are generalized to specific descriptions. So in this diagram you are able to see that we are moving from general to specific. Okay, that is what the concept of machine learning techniques. So machine learning techniques means what we are making the machine to understand, right? So in order to make the machine to understand the concept or understand the information what we want to convey, the concept, the model should be created, right? So that particular model must take the concepts, right from positive instance to negative instance. So that is what here it is given in that. Initially it is begins with the most general model. Okay, so it is what what's that? Sorry, the most general model which matches everything, where we can have the question mark. It is denoted as question mark. So then obviously wherever the question mark comes, it indicates that that particular instant is mapped with all kind of possibilities. Okay, so this is what the basic one. Then if there are negative instances, it specializes to general descriptions. So it should be conversed to towards negative instances, towards the general descriptions. Then suppose if there are any positive instances in that, any instances which leads to positive outcome, but really it is of negative in nature, that should be proved. Okay, so the positive instances prove the general descriptions here. That is what the concept. So right from the general, we are moving to the specific. Oh, sorry, right from the specific, we are moving to the general. That is what the concept here. But a general, it basically depends on the negative instances. General hypothesis mainly deals with the negative instances, and also the positive instances. Specific hypothesis generally deals with the hypothesis. Specific hypothesis generally deals with the positive instances. Okay, generally deals with the positive instances. You know the what is meant by positive instances as well as the negative instances, right? So the most specific model which matches the specific model which matches only one thing, right? So in terms of your machine learning, we are making the machine to understand the concept. Okay, so we are giving so many inputs as like that. Okay, we are giving inputs to the machine. The machine is get trained. Okay, the machine might be trained properly. Okay, if there are when once after training, when there are any test inputs given, okay, that test should be that test instance should be properly evaluated by the model what we are creating. Okay, so the model should be properly evaluated by the model which we create or what we are creating here, and based on that it should produce the output. Okay, it should produce the output. So if if there are if there are a lot of question marks, that means the information or the attributes are more general, not as specific, then obviously this will return all kind of possibilities. Some data, some model may, sometimes the model may represent the positive instance as correctly. Sometimes it may represent the negative instances as positive as a wrong one. So that there are the chances for getting possibility. There are possibility of getting more number of options for a single decision. Okay, that should not happen. So the machine learning techniques should obviously follow the instruction as per the training, and it should give only one proper output. Okay, it should develop only the one proper output. It should be a it should be a what's that correct one. Okay, so that in order to overcome these issues and all, we are supposed to applying the candidate elimination algorithm, where we have both, we will be considering positive as well as the negative instances. So you please understand the flow. We are converging here finally. So the negative instances comes from top to bottom with the concept of the general hypothesis, and the positive instances comes from bottom to top in the form of specific hypothesis. Finally, we will be getting a solution which is only one solution, where eventually the positive and negative samples may force the general and specific models to converge on a solution. So finally, it is converge to one. Okay, so that is what the diagram of version space. So in this diagram, specialization tree is colored in the red and the generalization tree is colored as green, and both are converged together here, and the final version space is denoted as what? Yellow. Okay, then the next one, candidate elimination algorithm. Yesterday we have seen that. Then I want to highlight the points alone here. So specific hypothesis, we have general hypothesis. Okay, so general hypothesis for most general, that is, we move from most specific hypothesis to general hypothesis for positive examples, and we are moving from most general hypothesis to specific for negative examples. Okay, negative hypothesis. Okay, this is for the concept. Then we have seen seen the algorithm as such. Okay, for both positive instances as well as the negative instances as like this. Okay, so this is all about for positive instances. This is what we have seen we have discussed yesterday. This is rest of the things are for negative examples. If the examples are negative, then how come we are moving from instance, I mean general instance to specific, like that is given here. Okay, then we are getting into this data set. Now we are building a model. That model should be should make the machine to understand well, and make the machine to give proper final single hypothesis as an outcome. Okay, by making the model to be model to get trained in a well manner, and we are supposed to follow some sort of rules. Okay, so let us get into this. Example here, the candidate elimination algorithm represents the vessel space by recording only the most general members, and also it also records the most specific members. Okay, so candidate elimination algorithm, how it performs means it specifies most general members as well as the most specific members. Okay, so that is what given here. It is represented in version space by recording only the most general members G, and also the most specific members S. By this only it is recording the data. Okay, so other intermediate members in general to specific ordering can be generated according to the need. Yes, so we will be generating. These are the other intermediate. There may be some other intermediate ordering can be there. Members will be there. So those can be generated according to the need. Okay, so let us get into this example. So here we are in this data set, we are having totally attributes like 6 important 6 attributes. Okay, so such as sky, air temperature, humidity, wind, water, forecast, and we are having one concept. What's that? Decision part, that is the enjoy sports. So based on this criteria, instances value, the decision will be taken either as yes or it can be taken as no. Okay, so here yes, all S's are considered as positive instances. All S instances are considered as positive instances, and all no instances are considered as the negative instances. Okay, so in this example, except 3 alone is the negative instance. Rest of the 1, 2, and 3 are 1, 2, and 4 are the positive instances. Okay, then we are looking to this example. Look into this diagram. Here it is shown that we are having the general hypothesis, and from general hypothesis we are able to we are able to move to this specific hypothesis, where we have the hypothesis were claimed according to its the composition of the attributes in terms of its general as well as specific. So where we will be applying the proving process if depends on the nature of the attributes or the combination of the attributes. Okay, so we will come to this diagram later. Before that, we explore the content individually. Okay, so look at this in the table. Initially, we are taking two hypotheses, that is specific hypothesis as S0 and also the general hypothesis as Z naught, okay, or 0. Okay, so Specific and general hypothesis will be developed as like S1, similarly S2, S3, and S4 as like it will go. So here all pi are representing all pi denotes the specific hypothesis, all question mark representing the general hypothesis. Okay, so G naught represents the general hypothesis, S naught represents the specific hypothesis. Okay, S naught represents the specific hypothesis. Okay, now we are supposed to move from instance. So since we are having yes, so initially we are having positive instance. This is of negative instance. Okay, the third one is the negative instance, and fourth one is again positive instance. Okay, so if the instance is positive, we are supposed to move from specific to general. Okay, so that is what given in the next slide I have written. So if the instance is positive, we have to move from specific to general. Okay, if the instance is negative, then we have to move from general to specific. Instance is negative means we need to move from general to specific. Okay, so S naught and G naught we have already seen that. Then we are writing, we are supposed to calculate S1. That means S1 is the since why we are moving to S1 first means since the first instance X1, no, we considered it as an X1. The first instance X1 is the positive instance. So if the instance is positive, obviously we will be moving to the positive hypothesis. Okay, that is what positive hypothesis means. Here it is the specific hypothesis. So that we will be getting the value as what? Getting the value as X. Okay, so here it is denoted as what? We are getting into the specific hypothesis one. So initially specific as well as the general hypothesis are written as S0 and Z0 with the values pi and also the question marks. Then we are now calculating the S1, where S1 is denoted. S1 is the for deriving S1 we are supposed to compare the S naught with all the other instances. Okay, so S naught to X1, S naught and X1 should be compared, and it should be compared with all the other instances too, because the machine learning, if in terms of machine learning techniques, if you want to represent the positive result, obviously all attributes should be positive. All attributes should be of positive values. Then only all attributes should have positive instances. Okay, so here we need to consider the positive instances. Suppose if the result is negative means even if there are only one negative instance, it may give you the negative value. Okay, so that is what, even if there are only one sentence as negative, okay, only one instance as negative, even if there are only one instance as negative, it may give, what's that? The result is negative. Oh, okay, it may give negative result only. Okay, so that is what the case here. Now we are comparing, so that now we are able to compute S1. Okay, S1 is the what's that? We are supposed to compare S0 along with what? X1. Okay, so S0 is obviously all the components of pi only. Okay, so all the combinations are pi only, so that it will returns the same value of X1 as the S1. Okay, so that the pi, anything compared with pi will be written with the same value. Okay, anything compared with pi will be written by the same value, so that you will be getting sunny, warm, normal, then strong, warm, same as it is like your X1. Okay, then the next one would be the so since it is a positive hypothesis, we are calculating the specific hypothesis only. So since it is a positive instances, we are calculating the specific hypothesis only. And And when similarly, and so that at the same time, in terms of your general hypothesis, it should come right from G naught to the current level. Okay, so initially we know that G naught equal to all question marks. Then G1 we are calculating, but G1 is highlighted that it is a negative instance. No, so but we are having the instance as a positive result. Yeah, its instance is about to produce the positive result. So here in G12, we need to consider all the other representation as the negative one. Okay, we need to consider this as the negative. Sorry, this as the general hypothesis, where again G1 will gets a question mark all along. Okay, so this is what G1. Then next we are coming to the see, we are comparing here the sunny, warm, high, strong, warm, same. So initially we have written X1 and what's that? 1 minute. So initially we have the hypothesis as like this. So sunny comma pi and it will return the pi. Then warm comma pi it is returning pi. Similarly it will go as like that. Okay. Then we are coming to the second row. So second row also was that a positive instance only. So that we have to move to the second row. So in the second row, we will be calculating S2. Okay. So here you can see that how you are arrived with this question mark. Okay. How you are arrived with this question mark while calculating X2? Are you able to understand what's the reason behind this? What's the reason behind this question mark here? Here we have mentioned the question mark. No. So why? How come we arrived this with this question mark here? Say, what's that? 1 minute. Uh, See, now this is the second. So initially we have calculated S1 as the same one. Now we have calculated S2. Okay, so S2 can be the combination of what S1 comma X1. S2 can be derived with the combination of S1 comma X1. Right. So that what we are doing here. So here we have the X1 as sunny and also warm, normal, strong, warm, same, and also it is a positive. Okay, then X1 can be, what was the value of X1 initially we have written? So X1 is written here as sunny, warm, normal, strong, warm, and also the same. Right. So here also we are writing X1 as such. Wait, I will show you. See, wait, here X1 and also what S1, right? So X1 we are having sunny initially, okay? That is what these are the contents of X1, okay? And and the value for S1 what we obtained from our previous step is S1 we obtained is first one same as the term one actually sunny, then warm, and then normal. Okay, sunny, warm, normal, and next one is warm, um, warm. Another one is same, warm and same. This is what we are at already. Then for we need to check it. No, so sunny and sunny. Okay, it will give you the result as the same as that of your what's that? 1 minute. 1 minute. I will bring the first one to. Sunny, warm, normal, strong, warm, same we have. Then sunny, now we are coming to the second attribute. Okay, so we need to compare this X2 and also this S1. Okay, now we are arrived with the S2. S2 means the second specific hypothesis we are arriving, so that S1 what we arrived is Sunny. Okay, it is okay. So that Sunny and Sunny both are the same content. So that you can write Sunny here. Okay, so it is a two. So here it is true as well as here also it is true. The same one. Then the second one is warm, and in here also in S1 it is warm. Okay, second attribute is warm. Here also it is warm. Okay, so you can written as it is. Then third instance here is what? Normal. Okay, so if it is normal, but here it is given as high. Okay, they are different. If they are different means they can be a general one. So there is no specific attribute we can derive. So the third can be a general one. Okay, so that is what it is given as question mark in S2. Then the next one is the then the next after third one we are having the fourth one as strong. Okay, so for strong in all the sites we are having the only one attribute, which is only one attribute value always stand for all the instances, so that we are writing as it is. Then the fourth one is warm. Here in S1 the fourth one also the warm. Okay, that is okay. Then the fifth one is same. Here in S1 the fifth one is also the same. Okay, fifth one also the same. So now we arrived with S2, where S2 is the combination of sunny, warm, question mark. Why we got this question mark is since that instances are different, we got this question mark. We are supposed to replacing it with the general hypothesis. Okay, so then next one is strong. Both are the same, and warm is also same, and same is also the same. Okay, so next now we have completed the first instance as well as the second instance. Now we are coming for the third instance. Okay, now we are coming for the third instance. So third instance is obviously a negative value. So when there are some positive instance means we have to go from specific to general. When there are negative instances means we have to go from general to specific instance. Okay, so here it is negative instance. So the result would be a negative one. So the thing what we are supposed to remember here is if it is negative, if any one of the instance is negative, then obviously the whole result will be negative. Okay, if any one of the instance is positive it comes, then it should be eliminated. Okay, so here we have in our previous slide we have written the G0, we have written similarly G1 also we have written. Okay, so G0 why we have written here is G0 can be what's that? That means general hypothesis is given initially as question mark. Okay, so this is what given here. Then next one is G1. G1 where we will be again comparing the G0 along with the rest of the attributes. So here if there are any particular attribute, any particular instance which should be reflected as positive, but it is reflecting as negative means it should be cancelled from here. Okay, so that is what the idea behind. So since we have first two instances as positive, we are having the general attributes G0 is question mark. Similarly, we have G1 also a question mark. Okay, G0 is question mark, and also because it represents the general hypothesis. Okay, G0 and G1 represents the general hypothesis. No, so that initially the general hypothesis are maintained as it is. Okay, so it is maintained as it is. Okay, so here it is given as Z not. Okay, next one. While coming to the Z12, here also G1 is again the same, because here also we are having the positive instance. There is no negative instance. That's why here also we will be getting the same result as like the previous one. Okay, this is what the case here. Then the next we are moving to the third instance. So third instance is obviously obviously consist of negative values. Okay, though, so it may returns the negative instances. Okay, so so that what we are doing is up to G2. So up to G2, we will be writing the hypothesis for general hypothesis as it is. Okay, general hypothesis as it is. While coming to the third one, G3, now we need to calculate G3. So for calculating this G3, we have to compare G2 along with this respective S2. Okay, so here, what I'm coming to say is here S2 we have as sunny, warm, question mark, strong, warm, and also same. Okay, then we are working with what S2 and also what's that? And also this X3. Okay, now you can get into this first attribute. So we are training the machine learning model to recognize the positive examples as positive and negative examples as negative, and how this training is happening by with the help of the instances. We are training the normal machine to reach the machine learning nature. Okay, so what it happens here is here with the help of what's this, I will write now, G3 I will write now, then accordingly you can learn it. So you can refer the final hypothesis you received from the positive instances. So what is the final hypothesis we received from the positive instances? They are the sunny, warm, question mark, strong, warm, and also the same, right? So here we need to calculate G3 as like this. 1 minute. So here we need to calculate G3 as like this. So first attribute, first one is here, it is question mark. This is a general attribute. It may be anything. It may this general attribute may answer for all attributes as true one. Okay, so this is what the general attribute. And in terms of your X2, we are having sunny, right? So it is a specific attribute mentioned as what as explicitly as available, so that we are combining the question mark and sunny, then we will be deriving with the result as sunny. Okay, we are receiving the result as sunny here. Then the second one. Okay, so if you put the first attribute and the rest of the other attributes can be of remaining question marks. Okay, so totally we have three attributes here. So the first attribute is sunny, then obviously it is denoted by rest of the attributes will be denoted by question mark. Okay, that is what G3. Similarly, this is the first attribute. This is the first attribute. Then we can try for the second attribute also. Okay, second one is the warm. Okay, so while we are coming to the warm here it is in G2 it is question mark, and in S2 it is it's having some values. Okay, so it have some values, so that what will happen now, then again the first part of this attribute will be question mark, and the second one what we have seen, second one it is can be filled with warm. Okay, so that the question mark, after that we have to write warm. Okay, then after we need to put semicolon in sorry, so we need to put a question mark in rest of the attributes here. Okay, so totally how many attributes we have? Totally 6 attributes. So question mark, warm, then question mark are now written as G3. Then we are moving to the third attribute. So you look here it is a question mark. Similarly in G2 it is question mark. So if both are general, we cannot utilize that case for training the model, because if anything can be defined and anything can be identified as a book or pencil or whatever it may be, then the model is not a correct one. It is getting failed at one point of time. So in order to overcome that, the attribute and its and its model should be examined with all the other attributes as given here. And if there is a question mark and question mark, then there cannot be a we cannot derive anything, so that we are leaving it. Then the next one we have seen is the warm. Here it is seen here as strong. Okay, so now what will happen? Now we are writing the third part of the general hypothesis in G3. So first one is we have completed, second two also we have completed. So in the third part it is already question mark, so that we will not compute anything, and we are moving to the third part. Okay, so in this third part here it is given as strong. Okay, here it is given as strong, and the question mark would be the next parameter of here. So obviously we can have the content as what, strong. Okay, so here I am writing as the next one as question mark, then warm. That you can write. After that, you can write this normal. Okay, so how come you are arriving with this normal? So we need to check the attributes which are more more positive, more which prove. We have studied the proving technique now. That means if the result is negative, but the attributes are if any attribute supporting or leading it to a positive instance, or the positive hypothesis, then obviously that particular attributes need to be proved. Okay, so that is what we have done here. Okay, then the next can be what we have seen, the another attributes like normal, where it can be so the rest of the attributes can be of what, question mark. Okay, how many attributes are here? Here it is 1, 2, 3 are the question marks. Okay, then the next one, we are moving to the next one. 1 minute. Normal we have written. Then we are moving to the next one, where it can be the question mark. First attribute we have completed, second completed, third also we have completed. The next one is what, the fourth one, right? So here we have the fourth one representation as like, where here we have seen that some sort of cold as an air temperature, no, so that it is, if it is cold and also rainy, cold, high, and wind also strong, and water is warm, then and the forecast is also a change, then obviously it will lead to the negative instance. So that here we need to calculate the fourth attribute as like this. This is question mark. Yes, we have this completed, this one and this one, and we have compared with this, and we have compared with this attribute too, and finally we have the warm and also the same, right? So where we are having the warm here, question mark and warm will obviously give you the result as warm, and finally we have question mark and question mark, question mark, question mark. Remaining attributes are like that as what, here we have the same, no, so that we have to put the rest of the things as negative one, sorry, general 1, 2, 3, 4, 5, and finally you have to write the as same. Okay, so likewise now we have framed G3. Okay, so in terms of G3, initially we have sunny, how we are arrived with sunny from S2, and also we have to arrive with the rest of the other instances. So if any general hypothesis means each and every attribute should be compared with all the other rest of the remaining attributes. Okay, so now you can examine, you can see that same, here we have an attribute as same, so but here it is given as forecast. Okay, so we received with the fifth attribute as same, but it is given as negative. Okay, sorry, if it is given as change, so that it should be that particular hypothesis which is leading the incorrect learning of the machine. Okay, because if it is what's that, if it is same, then it should give the positive response. Then if it is what's that? If it is same, sorry, if it is change, then it should give the negative hypothesis. So what will happen now? Here it is not part of this particular algorithm procedure, since it is the what is this? It is violating the rules of this general hypothesis. Okay, then we are moving to the next one. See here, that is what given here, but I'm writing the next hypothesis also here. After that, you can move to the previous one. Okay, so now we have written as G3. Similarly, at the other side, the S3 will be same as S2, right? Because we are not, please, 1 minute, sorry. So S3 will be same as the S2, because we are not, the third line is the negative line. We are not considering any kind of considering any kind of negative instances. So what will happen now? And now we have proved this also. Due to that reason, we have proved this also. So now what will happen now? We are calculating what S3 we have done it, I think, and we are calculating S4, and also the same manner we will be calculating the what's that, S3 and also S4. So here for S3 we have to give the inputs as like 1 minute. Okay, I thought of changing the color. It is not coming. 1 minute. It is moving. Okay, so now we have now we are arrived with what S2 as well as, sorry, S3 as well as the G3. Okay, so S2 only we have written here. Okay, again we can write. Okay, third one. So S3 would be that we are not calculating any specific hypothesis here because it is a negative instance, right? So next, so that the S3 will be same as that of S2. Okay, that is what I haven't written here, but it is the nature. Okay, so due to that, S3 is same as of that what S2. In what way you can written here? Written here is first one is sunny, another one can be is warm, then question mark, another one is strong and warm. Okay, and also the rest of the attributes. Okay, so what happened now? Sunny, warm, question mark, strong, warm, and another one is water. The last attribute is the same. Okay, last attribute is same. So S2 is same as that of your S3. Okay, next we are moving to the another attribute. Okay, so here, sorry, next fourth instance we are moving. Now in this example, the fourth instance is given here is sunny, warm, high, strong, cool, change, then the final outcome is yes. That means it is a positive hypothesis. So what will happen now in terms of positive hypothesis? We are moving to S4 now. So now you compute S4. Since it is a positive value, we compute S4 alone here. So S4 can be, how can we write S4? S4 can be a combination of what? S3 and also X3. Okay, then S4 we have to calculate by what's that? Again, I'm repeating the point. X4 and S3. From X4 and S3 we are supposed to calculate. X4 and S3 we are supposed to calculate. So what is that? What is that X4 now? Sunny is initially there, and also S4 here already in the attribute also the value given as sunny. So both are the same. You can write it as what's that? Specific hypothesis. You can write it as S4. You can write it as sunny, as both are same. And also in case of what? A second one, warm. Here also it is warm, so that you will be writing as it is as warm. And the third one is what? Humidity. Third one, it is high. Humidity, its value is high, is given here, but here it is given as the question mark. So that obviously we will be following the question mark here, because in the third, in this attribute, the question mark is written here, so that it will be representing the question mark only. Okay, then the next one can be, what's the next attribute we are having? Strong here. Okay, so the next attribute is strong, and another one there is also strong. Okay, so both of them are the same value, so that you will be getting again strong over here. Okay, then the fourth and fifth we are looking into it. So fourth one is given like what? Given like as fourth one here, it is warm, and we have another option for the alternate option for the warm is cooled. Okay, so that you can return here as the fourth instance as the what's that? This value, fourth instance here it is given as what? Again, the strong is there, both are matching, but fourth instance here it is given as what? Cool. But in our attribute it is coming as what? It is coming as like warm. No, so that what will happen is again it is getting mismatched, so that you will be writing the question mark. Then finally you are supposed to look into that. The S3 value is same, and the what's this forecast value given here is changed. So there may be the differences, right? There is a differences. So that differences should be highlighted properly in the write up of the hypothesis, so that we are getting question mark in fifth S4, and similarly we are able to get the one more question mark here due to the mismatch of contents. If there are different one, then it should be given in the question mark as added one. Okay, so then this is what the steps we have followed as we actually sunny, warm, then question mark, strong, warm, warm, and also the same. So initially how it has been taken, then after that how it becomes with the help of that candidate elimination algorithm or the procedure, so that we will be able to eliminate the candidates like which are not suitable for the hypothesis what we are expecting. So if it is positive, the hypothesis, if it is positive hypothesis or a positive result, like they can go out for enjoying the sports, in the sense it is positively. So suppose if they can go, they should not go out, in the sense that it is obviously negative instances. Okay, so that you can come to this this and all we have seen, right? So how we are able to get this question mark we have seen, and also and also how this how this missing value is given for the other two other two attributes too. Okay, so that finally we are deriving with that sunny, then 4 attributes, so then next one is warm, then 4 attributes, as like that the process will go. Okay, so once again look into this example. Here we can finally specify the general hypothesis as well as the specific hypothesis as sunny, and also too strong. Okay, so that we will be getting the general and the specific hypothesis as like that. And one more thing here I want to tell is the homework or if anything is given related to this, you are supposed to explore along with the rules what you studied here. Okay, so even though there are a lot of sources in that YouTube, they are little different from the concept what we are learning from this slide. Okay, you please move according to the concept given here, and you can have an understanding from that examples, but it should be explored in the manner what we are exploring here. Then we are moving to the so as such we are moving to G1, G2. Similarly G3 we have seen, right? So G3 we have seen, and as like that we are supposed to develop G4 also. So G4, where we will be having the representation from the what X4, and also this G3 3 previous content, so that we will be arriving with G4. So in this G4 you can see that, see this example at the end, you can see that 1 minute. You can see that this hypothesis, sunny, question mark, strong, then uh, question mark, then sunny, dot, warm, then remaining question mark, then warm, then the question mark, strong, and question mark, question mark. The thing here is, if there are, if the attributes are similar to that, there are, then there will be what's that? Strong elimination, strong consideration in terms of our finders, as well as the what's that? Finders algorithm, as well as the candidate elimination algorithm. And suppose if the attributes are similar to be a little different in terms of hypothesis, they are the negative. They will not be considered as a whole. They are part of the attributes will be taken for the account. Okay, so in this example, now you are able to derive it. Similarly, finally, we will be deriving with the final general hypothesis, which is G4, where G4 will be having the value as after computation. It may have the value as 1 minute. It may have the value as like the current table, and also we have some more tables too, and that should be examined further. Then, so that is what finally we are coming with the G4. So G4 can be of what? It is of sunny, and rest of the thing would be the question mark. Please explore as per your own way by understanding the PPT. Okay, and the rest of the others 1, 2, 3, 4, 5, and 6. No, so these are all the G4. So G4, where we have eliminated the or we pruned the result which are not supportable for the positive instances or the negative instances. If it is supporting, we kept only those instances, otherwise those instances also removed. So finally in G4 we will be getting as sunny, then rest of the question mark. Then another one is farm, and the next one is what? Warm, and the rest of the attributes were combined as 4 question mark. Okay, so that we will be we have derived G1, G2, G3, and also G4. So from this we are supposed to mention the all possible combination, all set of or all possible combinations. Okay, so in the Western space, so we have studied about the Western space. So what are the common attributes to be specified in this attribute is as mentioned here. Okay, now the timer, I will just to conclude this. So by combining all those general attributes which we derived finally, similarly all the specific attributes which we derived S1, finally we have derived the specific attributes as S4. We are able to combine, bring a final result of 6 different final hypotheses in the question space. Okay. It's time of 1 minute. 1 minute. I will conclude this. Okay. So by the way, it is completed. You just of this. I will post this problem in your GCR. You can explore this. Okay. I will take attendance now. 1 minute. I will take attendance.